Use the trapezium rule with 5 ordinates to find an approximate value for the integral of 1 over 2 plus root x between 0 and 0.4. Show your working and give your answer correct to 3 decimal places. So let's have a look at this then. I've summarized the question here. We need the trapezium rule from the formula booklet then, so let's just paste it in. Here it is here. So we need to put the values in then. We're going from 0 to 0.4, so A is 0 and B is 0.4. So I'll just put them in here. So we're going from 0 to 0.4. H that's mentioned in the formula, of course, is B minus A over N. So 0.4 minus 0 is just 0.4 on the top here. Now we've got 5 ordinates, so that means N is 4, because there's 4 intervals, isn't it? So let's put 4 in as well for N here. So H is 0.1. So 0.1 over 2 then will be 0.05, won't it? So I'm going to write that in directly here, 0.05. And then N was 4, as we said, wasn't it? So we need to remove that one and that one there. And let's write in the values. So we've got Y4 here, and this was Y3, wasn't it? So let's put that in. We go up to Y3. So put N minus 1 is 3, close the bracket, close the brace. So there's our formula then. We just need to work out the values. So we'll need the x ordinates first. So we're going from 0 to 0.4 in interval distances of 0.1. So x0, x1, x2, x3, x4. There's our 5 ordinates then from 0, going up in 0.1s. And the last one is 0.4, of course. So now we need the y ordinates, don't we? So put y0 in 1 over 2 plus the square root of 0 is just a half, or 0.5. y1, so you've got a 1 over 2 plus the square root of 0.1. And then y2, same again, same formula, but we input 0.2 this time. And we'll need to tap these out all on the calculator, won't we? And the answer needs to be to 5dp, so we need to work to 3dp, so we need to work to 5dp just to be safe, don't we? So there's our values then. Just move the page up just a smidge, and that's what we need to work out. So let's tap it in the calculator then. So 1 over 2, so it's 1 over, and there's more than one object underneath. So we'll put a bracket, and it's 2 plus the square root of 0.1 outside the square root, close bracket, equals 5 decimal places then, 43174, 0.43174. Now the 0.2, so go back, change the 1 to a 2. 40863, 0.40863. Next one, 0.3. 39251, 39251, 0. And then the 0.4. So let's go back again. And we get 37987, 37987, 0. So there's our numbers then. So we need y0 plus y4, so it's this one plus this one here. And then we need 2 lots of the ones in between, so times these by 2 and add them together. Okay, and it's all times by 0.05, so let's tap that in the calculator then. So it's 0.05 times bracket, the first and the last, so just add 0.5 to this, so it's 0.8. I'm just going to write it in one fell swoop. 87987. So I've added the 0.5 straight away, and then it's plus 2 times bracket, and then these 3 added together, so it's 0.43174 plus 0.40863. 0.863 plus 0.39251. Close that bracket, close the bracket at the end, equals 0.167 to 3dp. So that's equal to 0.167 to 3dp. And if we wanted to double check, we could just toggle back along our calculator and check that all the entries were correct if we wanted to take a moment to do that. And we could also then at the end of the exam, forget time, check these constituent parts as well to make sure they're okay. But this type of question is time consuming, so I wouldn't spend too much time if you get time at the end of the exam to double check things.